state has a particular definition. So for specific learning disabilities as a whole, here is our definition of learning disability. And I'll give you a chance to read this. And so I'm going to focus specifically on this last piece. And I know in India you call it dyscalculia. Sometimes that term is a little problematic because it does focus on just the calculations. And even this definition is focusing on the calculations. But specific learning disability in mathematics is so much more. It can look like difficulties in number sense, difficulties with memorizing facts. It can look like difficulties in calculations, but also faulty math reasoning. And so that's the piece that I really like to focus on because so many students have difficulty with word problems. All right, so how do we determine if a student does indeed have a math learning disability? Well, here in the US, we look at their grade level standards. And so in the chat, I am just going to post the example of the Massachusetts standards. So these are all the standards for all the grade levels, K through 12, of what typical students should be achieving at grade level. This is based on the Common Core math standards that we have at the federal level. So I'm not sure, I haven't kept up too much with the curriculum standards in India. Each board has different requirements, and so I'm not going to get into that because it depends on your school. It's so individualized, right? So we want to look at what are typical children expected to do. So we have to look at that. And then we have to look at, okay, if the student is not at the same level as his or her peers, are they able to catch up if we offer intensive intervention? And we want to use evidence-based, research-based intervention. And I can share examples of that later. And if the student is not responding to interventions we're offering, that can be a clue that there's something more going on, okay? So the student might also exhibit a pattern of strengths and weaknesses in performance and achievement. And that's typically how you show it in India using cognitive tests and academic tests. And I'm going to go over that in a minute. So in the US, we've moved to more of a response to intervention model. So we are noticing that students are behind their peers, and then we're screening, we're using interventions, and we're progress monitoring. So this is what it looks like in the US. All students, I don't have annotation capabilities here. Okay, so all students, this is your classroom, your regular ed classroom. I hope you can see my mouse. All students are receiving research-based instruction, all right? And we're screening all students. Students who are showing difficulties, they are then placed in small group instruction here. And so here's where we're looking at, are they responding to intervention or not? And if they're not, then we put them in this tier 3 at the top. And this is a very small amount of students, but this is typically where we see students with math learning disability responding to that instruction. Very intensive, very small group, maybe even individualized. So what you have in India is this psychoeducational assessment model. And so one thing that I would like to advocate for is that we use a variety of assessment tools. We don't just use the cognitive testing, the WISC or the Woodcock-Johnson, and the academic achievement tests. When I was in India, the cognitive test was normed for India, but the achievement test was not. So there's problems using assessments that are not normed for your population. So we want to use a variety of assessments, and we can even use interviews and observations of students' performance in math. And so that's what a lot of my research and work is around, how to conduct these interviews and how to conduct these observations so that you can see math learning disability warning signs. And of course, like I mentioned before, we want to make sure we're looking back to those grade level standards and seeing, is the student about 2 years or more behind their classmates? That is typically one metric we use in the US too. So in India, you might have seen some students receiving cognitive testing. And so that's the ability, their IQ, all right? And typically most students achieve similar to their ability. If they have this cognitive power, we expect them to achieve at a certain level. However, students with math learning disabilities or learning disabilities in general have they have average to above average ability in terms of cognition, but their achievement is lower, maybe 2 grade levels below. And so there's this disconnect, right? So this is what I'm looking at in terms of math learning disabilities and the cognitive versus achievement testing that's typically done in India. All right, so what are some other warning signs that you might see as a teacher? This is from a screener that I conducted in India. This was from my work at Maharashtra Dyslexia Association way back in 2013. And so let me explain what I saw when I asked this student, okay, here's a number line from 0 to 100. Where do you think 38 should go? So this is a screening tool for number sense. And so I'm not going to make any diagnostic decisions based on this tool. I'm simply collecting data about a child's number sense. And so a child with strong number sense would typically say, okay, so I see 0, I see 100, I know 50's right in the middle. And so 38 in comparison to 50 would be, and then they would place the number somewhere over here, right? So that's what a typical student would do. I'm always on the lookout for, how might a student do it that might have weak number sense? So this student in particular, and this was not the only task she had difficulty with in terms of number sense. She started at 0 and then made all these tick marks, 38 tick marks, and then she put her dot, not looking at the relationship between the numbers on the number line. Okay, so this is something I often see as well. Students may be slow to retrieve their math facts, or they might have maybe they're not accurate either, okay? And so in isolation, this could impact them, or it could impact them in their calculation. So you could see it in both ways. So we don't want to put too much emphasis on that fast fact fluency. We want to give them between like 3 to 4 seconds to recall each fact, because they might be using some sort of compensation strategy if they haven't memorized the fact, and that's okay as well. So what's something else you might see? I see a lot of difficulty with multi-digit calculation, as well as recalling the procedures, the subroutines within each procedure. And so this student, there's a lot going on here, obviously, with regrouping. So she regroups in the ones place, and then the tens, and then the hundreds. So what she did here is she did 8 minus 8 is 0, and then what she did was she regrouped and made this a 10, and then did 10 minus 8 and got 200. So another thing I see with students with math learning disabilities is confusion with these procedures, but also lack of self-monitoring. So if they would just look at this problem and say, 101 minus 85, that should be about, and they have some general idea, they estimate, and then when they actually calculate, they get 206. That should like set off warning signs, bells in their head, like, wait a minute, that doesn't make sense. And so that's another thing I see in students with math learning disabilities, this lack of, sorry, I'm getting some background noise, lack of self-monitoring. All right, lots of examples here. I see it a lot. I'm gonna go first on the example on the right. This is a student I just saw last week, and she definitely received the diagnosis of math learning disabilities at our learning disabilities clinic at Boston Children's. So this was actually an addition problem. And she was in 5th grade, so 5th standard, and she should have been able to add 2-digit numbers. And so her calculation was all confused. What she did was she added 9 plus 3 and she put a placeholder 0 here for some reason, and she regrouped the entire 10s and 1s and put them in the 10s place. And then she added 7 plus 8 plus another 2 and got 17, and she just kind of disregarded this 1. So strange kind of procedures. This is very rote. It didn't make sense when she was originally taught it, and she's kind of grasping at straws, trying to emulate what she sort of remembers. This is another student on the right, total disregard for regrouping with subtraction. I see this a lot as well. Sometimes students just go crazy with the regrouping because they learned it and then it wasn't solid in their conceptual understanding. So we don't want to assume students are making careless mistakes. I really don't like that when I hear that from teachers. There is no careless error. There's always a reason for why students are making the error, and it's not because of lack of trying. So just keep that in mind. Really dig deep when you're looking at students' work. This was, again, that student I saw last week. Another example of not self-monitoring. Total disregard for regrouping, but she should also have noticed 184, wait, that doesn't make sense. I must have done something wrong. No, she just steamrolled through it because she couldn't recall the exact procedure, and she was just trying her best. So be on the lookout for that. All right, vulnerability to complexity. So this particular student could do multi-digit multiplication when it involved like numbers in the 10s, like in the teens, but she really struggled when there were larger numbers, greater numbers involved. So here she did it fine. She used the procedure just fine when multiplying 2, but then when she moved to the 40 here, that's where she forgot how to regroup and move the digits. So she put her 24 and her 12 here, and she said 36 times 42 was 12,240. Again, lack of monitoring, okay? So I really always work with students about estimating first. That should always be our first step because that helps us with our self-monitoring. The other thing I see is students using very primitive or inefficient approaches. So this is an example in a word problem or an application. And the question is, there are 6 students, how many legs are there? So an efficient approach, if a student was struggling, they could count by 2s. But sometimes we see students just revert to tally marks and have to count all. So this is another thing I see in students. So a couple of examples there. When we think about students with math learning disabilities, we don't want to just think about procedural fluency. This is where a lot of teachers have complaints and they come to me and they're, oh, they don't know their facts, okay? Yes, that's one piece of understanding math, but we want to make sure that students understand the 5 strands of math proficiency here as evidenced in this image. We want them to have the reasoning skills. We want them to understand conceptually what's going on before we teach the procedures. And as the previous speaker spoke about self-esteem, we want them to have a productive disposition as well. We want them to know that math is important, they're gonna need it in real life, and they can be good at it. And Joe Bowler has a lot of work on math mindset. All right, so as you think about moving ahead, maybe you have students with math learning difficulties in your classroom. What are my suggestions? This summer I offered a course through Learn Studio. It's 6 sessions, all right? This is just basic stuff. I'm gonna have to work with you all a lot more to walk you through all of this, but ask probing questions. Instead of getting upset that students aren't doing it correctly, or we think that they're careless, which they're not, we want to figure out what is the root cause of their misunderstanding. There's a misconception going on somewhere. So if we ask probing questions, tell me how you did that. Show me with these manipulatives. Tell me what you're thinking. And just remember, you're not a diagnostician. Even if you're seeing all these warning signs, you need to go to a clinical psychologist, a school psychologist, or one of the assessment organizations in and around India to actually achieve a diagnosis. I want you to use multiple data sources. Don't just rely on the standardized test, but your interviews, your observations, and the student work samples are really key. And we want to make sure we're seeing patterns, not just a one-off mistake, but are you consistently seeing the same errors over time? That should also be brought to the diagnostician's attention. So evidence-based practices that you can implement in your classroom. And I go over this in my number sense class that's offered through Learn Studio. We want to develop conceptual understanding for students. This is for all students, not just students with math learning disabilities, but students with math learning disabilities may need more time in the concrete stage. So using manipulatives, and I'm going to give you some examples here. Then we're going to move to drawings, and then we're going to move to the abstract numbers. So you have to go through this CRA gradual sequence to really develop conceptual understanding. You have to offer your interventions through explicit instruction. Students need to see it modeled. They might need to see it modeled many times before you, and that's what you do as a teacher. And then guided practice is what we do together. So we're going to do this one together. I'm going to say one thing, and then I'm going to be asking you questions. What should I do next? Before we release the student to do it independently. Metacognitive skills. So what I was talking about self-monitoring, estimating, we have to explicitly teach our students with math learning disabilities how to do that. The metacognitive skills, thinking about their thinking. And it doesn't come easily to some of our students, so we have to explicitly teach it. Graph paper, simply using graph paper to line up our columns. A lot of students can have difficulties with organization. The other strategy is using an attack strategy for word problems. And I'm going to give you some websites to consult. So when a student is faced with a word problem, they often become overwhelmed. They see numbers, they just add them, and they're not thinking about the relationships and problems. So when I see a word problem, what should I do? Okay, those are attack strategies. So here are some examples of the concrete representational abstract approach. And this should actually be implemented not just in pre-primary or primary school, but we should see it in secondary school as well. Whoops, sorry about that. So the concrete, usually concrete manipulatives, we can also use virtual manipulatives. It bridges the representational and the concrete. And I'm going to give you some sites for that here in a moment. Here are 2 sites. I'm going to put it in the chat, the Math Learning Center apps and Didax. These are free virtual manipulatives that you can be using with your students as you're working with them remotely. So you can do the CRA sequence even if you're not in person. I'm going to give you some websites in the chat as well. I strongly recommend the National Center for Intervention, as well as the IRIS Center. So just to summarize, what should we be looking for? Well, a student that has a specific learning disability in math could have difficulty with number sense, facts, math calculations, and or math reasoning. We want to be on the lookout for all those examples I showed in terms of patterns, error patterns. We want to use evidence-based practices for students, and you're going to find those on the National Center for Intervention and the IRIS Center websites. We want to use concrete representational abstract approaches to teach conceptual understanding, and we also need to teach explicit instruction through gradual release. I do it, I model, guided practice, we do it together, and then you do it on your own.